will edit that I'm coming from
There's no
Switzerland
time.
by car with biogas.
Okay, yeah, so why not? Yes, that's very good. Okay. So our next speakers will be these two. They have been in the wrong place, so please come and give your talk. And they are discussing about solar home systems, and so this is a broad and nice topic.
Good morning. My name is Dipal Barua from Bangladesh, and
I'm Bhaskar SenGupta. I'm based in Edinburgh at the moment. I teach here at Water University. So two of us going to give a presentation for a system that we've installed in Bangladesh.
we are actually for last 2 decades doing a solar home system, but this time in the mentioned the solar home system. This time we're talking about the solar energy, not only solar home system. We met together in 2014 and 15 in this Laureate conference. Though we born in the same subcontinent, one in Bangladesh, one in India. We are together here for a few years, and so we design some solution for our problem. One is the electricity. So solar home system in 1990s we have done. It was in a large scale. Now almost 4.5 million solar home system installed in Bangladesh. Was I pioneered as a founding managing director of Gramin Shakti in 1996. But today we are talking about how solar energy can be useful for other problem. In Bangladesh, we have another problem, arsenic problem. You know, in Delta region, in India, West Bengal, and Bangladesh, even in Nepal, we have arsenic problem. Underground water, lifting so much underground water for cultivation for other purposes. So that creates a arsenic problem in the underground water. So the public health department now check every tubewell for drinking water, and they see there is a arsenic. The level is very high, so they give a red mark. So they can use it only for clothes washing or other purposes, not for drinking purposes. So we are facing the problem for many years, but there are some solutions, but we are looking for something sustainable solution, because we are talking about the solar energy, solar irrigation, we are doing it. So how the lifting water underground and without any chemical ingredient, how we can make a naturally clean water edible. This is our challenge. So we established the piloting in one school in Kumila districts. There are a lot of arsenic problem in that area. So we decided to one primary school. The children are attending this school. I think so we took a permission from the school, and the school had teacher and the board agree, yes, you can try as a Bright Green Energy Foundation, my foundation. We established a pump, 1.5 kilowatt, and then 1,500 watt. We give the solar panel and pumping water. So we made it now remote control from Dhaka. We can start even, and then the water comes, and there are 2 tanks. There is an oxidization, so showering the water and then oxygen exposed to oxygen, and then this water goes level. So this will explained by our friend scientist, chemical scientist. He will explain more detail. But solar is working very well because we put the solar panel in the rooftop, and then actually people are now we are not allowing to drink the water, because we are taking the water and take it to the public health department, and they give a result. So initially it was 239 the micro gram per liter. Now it's come down to 30 after 1 month. But we are looking for the World Health Organization. He's a master of this. So we are looking for a 10. But in 1 month, the water color was peculiar. Now it is much more clean. Gradually is improving. Recently we had a talk with the school children, and we see there is a huge enthusiasm. So we are going to inaugurate when the health department say it is 100% safe to drink this water. So if it is successful, we like to do another 2 or 3 pieces in different places of the country. And if it is successful, we like to do it whole Bangladesh. Bangladesh now around 20 million people are affected in that particular area, different particular area, the arsenic problem is there. So we can, you can see the technology, how bringing water from the underground and the 2 tank, and then oxidization and goes again in the ground level, and then they neutralize. So there is no chemical agent we are putting it. So solar is working very well for pumping the water, and then 2 tank design such a way, the Professor SenGupta design, and then now we are trying to train our engineer how they can build the system, and remote control is there. We can see how much water is there and how much water in the tank and goes down. So we like to train the school teacher, and then gradually they can run it. But we can create a technician so they can earn a small money and they can maintain it. So we are looking for a sustainable model. But first we look how this work really at the ground level. The groundwater is pumped by a submersible pump. This water oxygenated and then shower heads and stored in a rechargeable and delivery tank. No chemical oxidants is used. So this is the whole process, and I think we'll talk later on about, but you know, the data huge the problem, so arsenic problem, and we put it. We have a battery bank because there is no electricity. So we like to put battery for the current we can store, and in the evening also, in the night also. So a continuous process we are doing it. That we trained 3 engineers so far. They are very master on that. Now we like to do it other area also. This is solar panel and the school. I think the Professor SenGupta will explain how chemically we are treating water naturally and is drinkable, and we are there are a lot of demand so that we can do in other places, but how it is cost effective and sustainable, and really the water is very clean, and the people can drink it.
Good morning, everyone, and thanks for coming. As Dipal mentioned, that we have been discussing this technology and how to implement it in Bangladesh for a period of time. And then finally, we have come to a stage that we've installed the plant in January this year, and is operational now. It takes a bit of time because it's bacterial. It's bacteria mediated in the subsurface. It takes a bit of time for the bacteria to establish. As you heard from the previous speaker, even for a biogas system, a digester, you need a bit of time for the bacteria to acclimatize. So we started off with the waste from dairy industry or animal waste, and then gradually acclimatize the bacteria to human waste. And one small thing that crossed my mind, that the main difference between the UK operation where I live and work and in other parts of the world, for example, India, Bangladesh, and a lot of other African countries, where many of the places I've worked in the past, the main difference is in the UK and other European countries, you'll be talking about a lower temperature operation. Typically, we call it mesophilic bacteria at a low temperature, 35, 36 degrees. Whereas in the tropical climate, you will be talking about thermophilic bacteria, the whole acetogenesis process where you produce the methane gas that's far more efficient because you're operating at a much higher temperature, above 55 degrees centigrade. So that's the main difference you find the operation in 2 different parts of the world. But coming back to this process, I'd probably go back to the earlier slide. Sorry, just go back. Yes, this is the process. See, what happens in case of arsenic release in the groundwater is the source. The source is hills again. All the mighty rivers like Ganges, Brahmaputra, these rivers brought in enormous amount of silt over thousands of years and deposited the silt in the alluvium plain or the flood plain in the lower Bengal Delta. And this silt, due to some strange biochemical changes, started releasing arsenic. And the change occurred because of the change in the irrigation and the agricultural practices with the Green Revolution. The new high-yielding varieties of rice demanded much more water, much more fertilizer, and that in fact reached this fertilizer-rich water, reached the subsurface and started this kind of reaction which produced arsenic. Now, one of the ways to prevent that is to pump controlled amount of aerated water, that means oxygen, back to the system. So satisfy the demand for electron acceptor, in this case, using oxygen for that reaction to stop further degradation of arsenic-bearing minerals and try to put back whatever is there in the water back to the system, that means into the soil, in a way that existed for millions of years in a very stable form. And that takes time, because any bacterial process is a slow process. It takes time to happen, and we slowly acclimatize the bacteria which have never been exposed to oxygen in a higher level of oxygen, and that takes time. It's a slow process. So in 1 month, we have seen a drop in arsenic level from 239 micrograms per liter down to 30. In a month's time, it will drop to 10, and this is my experience. And this kind of process does not use any chemicals, does not produce any waste, and in Bangladesh plant, we have not even produced 1 milligram of waste during the course of operation, and does not require any grid energy necessarily. So we're using solar plant. This case is super green process, no grid power, no waste, no chemicals, and submersible pumps that we use in this process are very durable these days. They run for 25, 30 years. I've worked in America with a submersible pump, which is 50-year-old, still going strong. So this process has very little maintenance cost. Once you install it, it just goes on and on. And as we just heard, we can now operate from in another location, completely autonomous systems. Nobody has to touch these systems, and it just goes on and on and on. And hopefully, when you come back next year, we'll be able to tell you more about it. And looking for a very bright future. So thanks to Bright Green Energy Foundation for joining hands with us, and hopefully we can tell you more stories.
Thank you very much for this nice story, and I hope you will be very successful. Well, I would like to ask a question. These mechanisms are working now at a very low. Oh my God! It's only a small.
We can scale it up.
What about
this system?
You have done this already, or
you have installed in many countries. And this autonomous system I first installed in Cambodia in 2012, but those are not remote controlled. They are, of course, timer-based systems, so he wants to go a step forward. So these days, automation is simple. So he wants to run it from his bedroom, so that's his choice. He can do that. He can run it from his phone anywhere. It's, like I can, set my alarm system from here or anywhere, through the phone. So it's very simple these days.
But what is the turnover of water per hour?
This system can produce up to 10,000 liters. It's a smaller system. There's no demand for a bigger systems, but we can go up to 100,000 liters using this system. 10,000 liters every day. Every day.
Okay.
So it'll go on for 25 years without any cost. Because if he has put quality panels, I believe he has used quality panels, if he has done it, they're not cut costs there, so it'll be fine. Roughly that, yes, and there's no other cost for next 25 years.
Initially, cost is a little bit high because we are using the best panel, best everything, just to see the result. Then we will try to cost minimize in the later on, because and we put more engineers. They are traveling a lot because we like to learn every piece of things, so that the next one would be much better, and the third one, then we go for a national program. So that, because solar energy we have a knowledge for 2 decades, but now the pump we have a knowledge. Irrigation, 600 irrigation pump we are doing it, but the arsenic is a huge problem. First for the drinking, maybe in the long run how we can replenish the rainwater in the shipping and then improve. So that's where I'm thinking also in the future.
One final point is, sorry, I'm coming back to this. WHO recommends that maximum. So let's just finish very quickly. Maximum daily exposure should not exceed 200 micrograms.
Thank you.
But if we keep a minimum value of 10, then you also have like 5 liters will contribute over 50 micrograms. But don't forget about the rice, vegetables, other crops. fruit. So that also, contributes to arsenic exposure because soil now has very high levels of arsenic. That's the reason Dipal is concerned. I'm concerned. How do you use make irrigation water safe so that at least we continue to reduce the arsenic level in soil, so the grain crop is safe. So anyway, coming to your question, yes.
I would like to ask, this sounds like a very successful story.
Yes.
It appears that you have installed these mechanisms, places in Bangladesh, is that
Yes.
correct? And the price of it appears to be about $8,000 initially. So I know that the income in Bangladesh is quite low, so who pays initial money for you to install these things in communities?
Actually, we paid from my foundation. This is a kind of a research, action research, but hopefully this will create a lot of the health issues, social issues, and in the long run, we can go to the any bank or CSR fund or anything. We have to create a business model. This one is just we are trying to find a solution. Then how to initially we contribute the money, no grant money.
So majority of the population now uses bottled water, but this
Okay.
will cut the cost.
Thank you very much for your presentation. Thank you very much for good presentation. It's very attractive. I have two technical questions. The first is that what is your dynamic head in using your water to pump? And the second is I have seen that the tilted area, tilted height. What do you use the tilted angle where your panels are laid down?
Okay.
How do you use that? Is it different from different country, or I
So
see
first the
it is
head.
horizontal?
Yeah, we have got the question right. There's a head. So we are talking about the shallow aquifer, where the typical water table is at 25 feet, 30 feet. So it will raise another 30 feet. So 60 feet is our total head. But with the 1.5 kilowatt pump, it's not a problem because you get enough head. Sometimes you throttle it to reduce the delivery rate. So pumping wise, it's not a problem. It's got 1530 watt panel, that's adequate. And if you look at the available power, we get enough energy from say 8:30, 9 o'clock in the morning with the sun angle, sun path, taking the mean values during the summer and winter. We get an average pumping time of 8 hours during the daylight hours, and we also have the battery backup, so batteries are charged. So we usually have 2 pumping sessions in a day, so that's after roughly 3 hours, and rest of the time batteries are charged to run the system, even in the evening. So that's not been a big issue to us. But the critical issue here is, how do you balance the entire cycle? We haven't gone into the details. There are many complex issues here, because the bacteria has a certain need for oxygen. How do we match that with the total time cycle? So that's a complex issue which we have handled very well in this case and many other countries. And this comes from experience in a way, because subsurface bacteria, in fact, the characteristics change quite a bit. But once you do a bit of analysis of the data, you exactly know what to do. And it's typically a fermenter. People who have run fermenters, you'll know exactly how it works. So it's basically running a fermenter with controlled supply of oxygen, with a controlled timing of operation, and therefore, it's not a big issue for us in a pumping rate or how to use the available energy because of a battery backup. Some cases we don't have battery backup. Our plants in Cambodia, there's no battery backup. Still, we manage it very well because we know exactly the sun path and available hours. Average sky factor, there's another factor. Okay.
Any questions? I think the panel put in the south face, 23-degree incline, so that most of the time they get a sunshine. It's okay?
We have time for one question more, if there is
Any final question?
one.
From the
So if there is no final question, I would like to ask you, don't excuse me,
Neutralize the arsenic problem here. How do we neutralize?
We don't neutralize. We reverse the process. We reverse the process.
Okay.
What we do is,
And how do we check that arsenic is removed from the water?
yes, that's his business. So wherever you go, any country, we have testers. We know exactly. We have meters and all to check on the spot. But for final analysis, we have to send the water samples to certified labs because you need instruments like AAS, ICP in the laboratories, research laboratories, like here at Watt we have, AAS, other places ICP. So in Bangladesh you have AAS, which is very
Bangladesh,
good.
we have a public health department and they have a facility for testing water.
But it is not yet tested.
Now we tested already.
Already tested?
Yeah, we mentioned that 239, it comes down to 30 after 1 month.
So the target is, all the Bangladesh standard is 50, our target is 10, because that's WHO standard. And we typically need 8 to 12 weeks because bacteria mediated. We need about minimum 8 weeks, so I'm hoping that next results will show that we are below 10. And in the Bangladesh
And
laboratory,
this,
they
and
use
this
AAS.
arsenic problem is a mineral problem or
It's a
any
mineral
other
problem. It's irrigation problem, agriculture problem, and mineral problem. It's primarily the bacteria. That's all other nutrients, except we call it electron acceptor in a subsurface. And that's where they don't find oxygen. Oxygen could be a very good electron acceptor. When oxygen is not there, bacteria produces enzyme to break down arsenic-bearing minerals. So arsenic 5, which is more like a precipitated, very less toxic form, that accepts 2 electrons, becomes arsenic 3, which is 50 times more soluble and 50 times more toxic. That's the problem. When you talk about total arsenic, that doesn't tell you the story. The story is how much arsenic trioxide is there. And that's the real poisonous one. So unfortunately, in water, that's mostly AS+3, which is trioxide. So anyway, they don't have the speciation facility, but we know from other tests it's primarily arsenic trioxide.
Okay, thank you.
Previous slide, which one?
No, but the time is over, I'm
Yes.
sorry. So the next speaker would as well have time enough. So please,
Sorry for the
you
overrun.
can, yeah, so you can talk with him.
Oh, certainly.
There
Thank
are
you. We
many
are
days
available
left, and thank you
the
for your,
conference, so you can talk to us. No,
yes,
thank you.
of course. And